Good afternoon, everyone. I'm Jan Lahoda, Honza Lahoda. I work for Oracle. I work in the Java platform group at Oracle, and specifically I work on the Java C compiler. That is the compiler that compiles the Java source code to Java class files. And today I would like to talk about new features in Java. I had to restrict it a little bit due to the time constraints, but I hope there will be some interesting things for you. And I wonder who are Java developers here? Okay, that's good. And do you use JDK 24? Okay, 21? Okay, so you, at least someone will learn something new, I hope. And so what you may know, Java had used to have a very long release cycle, or long release cycle and not quite predictable release cycle. But basically with JDK 9, or after JDK 9, it was changed, and there is a predictable release of JDK every 6 months. And some of these releases are designated as long-term support releases by some vendors, let's say. And these are like these 3+1 that is upcoming right now. And it's right now is basically that the LTS release is every 2 years. And one aspect of this fast release cycle is that like we typically cannot like do some full feature in 6 months. Like I mean design, implement, and then like verify that it works in like real world scenarios. So what we do is that we sometimes introduce features as preview, which means that they can change, or they can be finalized, or they can be removed as it turns out that that's necessary. You may know that we have actually removed string templates because it turned out that the feature needs some more deep redesign. Some APIs may be incubating, but we won't get into incubating today. And all this is done under some process that is called YEP, JDK Enhancement Proposal. And the last JDK released was JDK 24 in March this year, and we actually had 24 YEPs in that release. But like the number wasn't planned, the number of YEPs, but it was nice. For JDK 25, if I counted correctly, there are 18 YEPs, which is still like a pretty big release. And today I would like to show you very few features, recent, maybe some upcoming, depends how you define upcoming features in Java. I will be talking quite a bit about JK 25, which will be in September. The JK 25 is feature frozen now, so don't expect new features, but there is a chance that the feature still may change because it's not released yet. And every preview feature and every feature for a future that I will be talking about may change, as obvious. And I apologize, I will sit down because basically I will try to do demo from now on. And yeah. And so I will actually start with a fairly old feature. It's from JDK 11, which was released in 2018. But I think it's really underrated, and that is source launcher. So imagine you write a simple class like this, and you want to run it. So the traditional way to do it would be that you compile it with some Java compiler, then you get a class file on the hard drive, and you run the class file, right? But I don't know, maybe you don't want to do it because of Hello World, yeah, right? So since JDK 11, you can basically use the Java launcher, the like program that runs Java programs, and you can pass source code into it. It will compile the source code on the background automatically to memory and then run the code from memory. So I can do this and it will run. But now let's imagine I have like this nice API that can say hello for me, so I don't need to write say hello. And I would like to use the API here, and let's see if I will be able to. And in JDK 11, this wouldn't work, because in JDK 11 there was only one, the source launcher supported only one file. Since JDK 22, the launcher can find the source root and can find another adjacent source files, compile them on demand, and like invoke methods on them. So if I will use some recent JDK and run this, I can actually run program that has more than one source file, and I can run it as source files, which is like not really new, but I think it's really nice, and maybe many people don't know about it. And in JDK 25, we finalized a group of features that is related to this, but distinct. And it has several goals, but one of the goals is to help beginner developers with starting with Java, with developing in Java. And if you will look at a source code like this, and imagine you are a new developer or a person that is trying to learn to code from scratch, and now you see some public class, static, and some weird parameter here, right? And what do you take from this? Like, it's weird, and you just take it like some words that you need to type for the things to work, right? So as part of YEP 512, the compact source files, we can like remove the enclosing class like this, and the compiler will synthesize class around that, because like Java still need classes. We just don't need to put the main method and things like this into a main class, into a class explicitly. There are some restrictions what we can do, what we cannot do, but for programs like this, it's perfect. And I can, if I want to, I can have fields here. That's okay. I can have multiple methods. That's okay. It will be all wrapped in one class for me. As part of this YEP has, or this feature has several parts, or we can do several things with it. Another is that the way the main method is invoked has been improved or changed, so that we no longer need this public static here, and we no longer need this parameter for command line arguments. And it works like the launcher will look at the class, it will find the main method, it will say it's not static, so I will create an instance of the class, and I will call the method on the instance. So there is not much magic here. This is a normal instance method. There is no like implicit static or implicit public. It's a normal method as you would write it for this. Just the launcher knows how to call the method. And another part of this is something that's called simple I/O, which is just I/O. Like the class is called I/O right now, or will be called just I/O. And instead of like saying system out print line, I can just say I/O print line, which is shorter, hopefully, and more nicer for beginners. And I can also read some input, so I can do something like this. Let's fix this, and then I can and let's keep it short. So I can actually use the simple I/O class, or the I/O class, formally speaking, to read from input and to write to output, which is normally not which before wasn't that easy, I guess. And yeah, I cannot type. And if I run this, it will really ask me, and it will print the output. And there is another aspect to this whole feature, like let's help people write simple programs, or let's help beginners. And that is, imagine I would like to read something from network, and I don't know, let's type something that might work, at least. And yeah, like this, and I have tendency to write system R print line instead of O print line. That will take a while, and I could do something like this. No, it's not O, it's in. Could do something like this, and I need obviously something like this, and like. You may notice I didn't need to import anything. Like I am using IO exception, which is from some Java IO package. I am using URI, which is from JavaNet package. And I don't need to import anything. And the reason for that is that for these compact source files, all the top-level types from exported packages from the Java-based module, which is the most baseline module in the JDK, are imported. And that is only for these compact source files. But it's not some too much black magic, because the feature is and because it's only in this compact source files. If I would wrap this into a method, into a class, then suddenly I need the imports, right? But I say it's not too much black magic, because the thing how it works is that we have a new feature that can import all the public exported types from a module, and with some more features attached to it. And it's called module import. And the only trick for the compact source files is that this import module Java base is implicit in the compact source files. So yeah, this is. So I think this is nice for beginners, and also like if you want to write something very simple, you may just type void main and start coding without the class. Yeah. This IO, like, yeah, the question is whether the IO is required. Like, yes, the print line is no longer imported automatically. Yes, it used to be. There used to be another automatic import for the content of IO, but it's no longer the case. You actually, if you want to use the methods on IO, you need to type IO dot something. Yeah, that's the final state in JDK 25. And yeah, and now I would like to switch to some language feature that you may know. Also, there are not that many people using JDK 21, and that is pattern matching. And for that, imagine we have some parser for expressions. So we have some expression, and we can parse it into some IST. We have some operations. The operations have operands. The operands can, again, be some operations with some operands, and so on. And let's see how we can model this in Java. So we can have some record or class that represents the at node, which has some operands which are against some nodes, and for constants we have the literal node which just holds some value. And let me just like make a detour. This record, I don't know if you know, that's like a simple header for data. It's a class that has like final fields for these for these components. It has accessors like methods to get the values out. It automatically has equals hash code to string based on these components. So it's a simple holder for data that I can write on one line without like writing tens of lines of code to implement this. And we represent the AST node as the base node is called node here, and the interface is sealed, which means that only these types are permitted to implement the interface. And if I would like comment out this parenthesized node, it will shout at me that the compiler will shout at me that I cannot implement like that the class is not permitted to implement the interface. And now for the pattern matching, let's imagine we have some method that wants to evaluate the value of an AST, like what's the value of this expression. And like the pre-JDK21 way is maybe this, or one variant is this. Basically, if n is an instance of at node, then create a new variable an for me and put n, the value from n into this new variable. Since JDK 21, we can use the same in switches, right? So we can do this. And we can, of course, use also switch as an expression that is not really new either. So I will say just return here. And so since JDK21, I can write this. It means basically the same as before. If the object in n is of type at node, it will run this case. The reason why the node was sealed is that node is sealed, and I am covering all the possible variants, all the possible permitted subtypes. I don't need this default here because I've covered everything. And the compiler will synthesize some default for me to be sure that if something changed, there will be some notification, basically. And there is another level to this feature. And if you look at this n here, we are actually not really interested in this mul node, right? We are interested in the operands of the mul node so that we can run eval on them recursively on the components. So what I can do is I can write this and just do it like here. And this basically says if n is a mul node, then please split the mul node into some parts and further run pattern matching on the parts and possibly create new variables for me. So it basically deconstructs the mul node for me into components that I will then use. And as I say, this is not a variable declaration. This is another pattern. It will take the operand and it will do pattern matching on it again. So I can write literal node var value here and then just use value. And if the first operand of the mul node is a literal node, it will create the variable value for me, put the value inside, and I don't need eval anymore. And give me the value from the literal node. And just like the obvious, what I can do is like something like this. You probably could guess that I can, if the value is 0, I don't need to compute anything, and I can use underscore if I don't need a pattern. But the underscore wasn't in JDK21. That's newer. And now, like the reason why here the nodes were records, that wasn't an accident. That's actually required right now to make this deconstruction work. It needs to be records, because there is nothing that would allow someone who is writing a class to say, let's split this class into some components or into some parts, which is like the inverse thing compared to constructors, right? What if I, for some reason, and it needs to be final and it needs to be static, what if I, for some reason, wanted the literal node to be a class? Like, right now, frankly, you cannot, because the pattern matching, the deconstructors would no longer, the deconstruction pattern would no longer work. So, let me show you. The deconstruction no longer works for literal node because it's no longer a record. So now I am switching to something for the future, something that we are looking at right now, and that is like allow developers to deconstruct classes to some components, which is like the opposite of constructors. Like constructors will, from components, create an instance of a class. The constructors take an instance of a class and produce some components that you can maybe then pass again to some constructor. And I very specifically don't want to show you how the deconstructor is implemented, because that's being discussed, the body of the deconstructor. But there will be some syntax, some way to write. This is something that can take instance of this class and split it into these components. In this case, we can output just the one int value. And after that, I can use it again in the pattern matching as a deconstruction. And for this, actually, like for the future, there will be more declared patterns like this, not only the constructors, but yeah, that's for the future. So yeah, let's see when this can be at least a preview feature. And now I would like to show you. I don't know if you have a lot of experience or knowledge about Loom virtual threads. Okay, so yeah, let me show you. So this slow server is some server that that can handle very many connections, but it's slow to answer. It takes 100 milliseconds to answer to every request. Regardless of how many requests there are made to the server, it will take 100 milliseconds to answer. And then I have this code that tries, and the server does that. We ask it, please give me some character, and we give it index of a character that we want to read from somewhere. So we provide it a number, and it returns some character. We provide it another number, and it provides a different character. And if you want to read from this server, we can do it maybe like this. We will synchronously read the characters into some character array. And the actual reading, the actual task, is like relatively straightforward, and it's like synchronous, right? We open a socket, we say which character we want, we wait until the server answers, and we take the output. And this works. We do one after another, and this works. It's just slow, but it works. Now, we have read 14 characters. If you would read a few thousands of characters, it probably would wait too long for us. So what we can do to make this faster? What we can do is to, I cannot type, is to run these requests concurrently, right? So I could do some pretty straightforward change, not like this, some pretty straightforward change to the code like this. And if I do it like this, it will basically use as many threads as needed to run the task. So if I run this now, it will read 14 characters, and that's okay. But if I try to read more characters, it will not be okay, because this is running with some limited memory, and I run out of memory, which is like problematic, because sometimes you have a lot of connections like this, a lot of stuff running like this. So the virtual threads is that I will just say, please use virtual threads, and it runs fast and it runs efficiently. And the way this works is that there are used virtual threads that are threads managed by the Java runtime itself. And if a virtual thread should be run, it's put on some heavyweight platform thread. It runs. When it blocks on I/O or something like that, it's like unmounted, removed from the platform thread, stashed somewhere on the heap. A different virtual thread that is runnable is put on the platform thread. And this is much more efficient, because the virtual threads don't consume so many resources. And yeah, and then this then continues like with structured concurrency, which is some feature that allows us to better manage failure modes. But let's not get there, because we don't have time for that actually. And yeah, so we are getting to the end. Let me just mention that there is an extension for Java for VS Code made by Oracle, by the Java Platform Group. It's called Java on the VS Code Marketplace, and it's based on Apache NetBeans, which is based on Java C. And to some degree, it allows like use Java C from the JDK it's running on to do the editor stuff. So you can use it to like sneak peek to new language features in Java, for example. Okay, and if there are questions, I will try to answer them. I don't know I don't know how much time we have. That's okay, yeah.
8 minutes into
yeah, okay. Or we can go back, I don't know, for a structured concurrency if you want. It's code that you don't want to show. Oh, the question is about the deconstructors, like the way to split it. I don't want to show it because, to be honest, I know it will change from what I have written here.
Maybe it would be good to see also the way, how we are getting to the final
Yeah,
APIs.
yeah, rather not, sorry. I apologize for that. Yeah, please.
I don't know the specifics, but in Java 21 there was a deadlock or potential deadlock issue with virtual threads. Especially when code was not specifically written to work with virtual threads was interacting with them. Has that been, I don't know, improved in one of the current JDKs?
Yeah, okay, so the question is about deadlock potential related to virtual threads. Like, I would say like there was a potential to starve the platform threads, like so that all the platform threads would be blocked running some virtual threads. That there was a bigger potential for that. There was a bigger, yeah, because, okay, what I didn't say is that like there are as many platform threads, right now there are as many platform threads as there are CPUs in the system. So if there would be like as many virtual threads running, doing some heavyweight CPU work, these platform threads would be running just the virtual threads, basically. But in JDK 21, there was another problem, and that is that when the code in the virtual thread was synchronizing, it like pinned the thread on the virtual thread, and it didn't allow it to be unmounted from the platform thread, and that has been fixed in JDK 24. So yeah, in 24 it will be like the LTS. The next LTS is 25 this September. So the specific problem with pinning for synchronized that's gone now in 24 and will be in the next LTS, basically. Okay, the question is about pinning because of native libraries. I don't think that's going away. I am not an expert on Loom, but I doubt this can be changed, personally. Yeah. Okay. So I don't know, do you want to finish or do you want to see stretched concurrency? Okay, let's go back to stretched concurrency. For 5 minutes, that will be okay. Let's imagine like the server that I have has a bug and it will sometimes stop responding or like fail to respond. And if I wrote the synchronous code like this, then yeah, and I need to increase the number of characters to be read. It will just fail basically silently because it will throw an exception here. The exception will be logged into some logger. And in this case, because I don't have logging set up, it will be just like, it will just vanish, which is not really nice, right? I would like to find out, ideally somewhere here, that it failed. Because that is the place where it should fail, right? Not some weird stuff. And I could do it with completable futures and so on, but it's ugly. So the JDK25 way, okay, so there is a preview for stretched concurrency, and the JDK25 way to use stretched concurrency is that I open some scope, and I put the tasks into the scope. These tasks will be automatically run using the virtual threads as if I did the virtual threads executor. And then I will say, please join here. And this will run the tasks. And on this place, it will wait until all the tasks are run. And if any of these tasks failed, it will fail on this place, which is most likely what I want. I want to fail here because I know the context, I know what to say to the user and so on. And it's easier because I don't need to do something with completable futures, right? So you can see it actually failed with an exception here, which is what I wanted. So this is nice. There are other ways to. This is the like default behavior when I do open. There are ways to change the behavior, so you can customize what will happen. But the default is that this will like that. If any of the tasks fail, it will fail everything, and it will attempt to cancel all the tasks that are tasks that are still running, basically. And there is also like a way, which we probably don't have time anymore. Like this is it is a little bit ugly to fill the data like into an array. So there is a way that is not so difficult, but not for 2 minutes, that we would actually return the value through the scope and get out of the scope just the values. But I probably cannot try this in 2 minutes. Yeah. So I guess that will be it. Yeah. Thank you.